Hi there. We looked today in class at the natural logarithmic function rule for integration, which says that if we let u be a differentiable function of x, then the integral of 1 over u du equals the natural log of the absolute value of u plus c. Okay, so we're going to do 3 examples demonstrating this rule. My encouragement would be maybe kind of watch through the first one and then try the next 2 more so on your own. That way you can make sure you're comfortable with the rule. And we're going to keep it fairly basic here at the beginning. Just kind of 3 straightforward rule applications. Okay, so all of our examples here are going to have the same directions, which are going to be to find the general solution for and so then the first one here, example 1, is going to be y prime equals 8 over 4x minus 1. Okay? So when we're finding the general solution, we're going to go ahead and take the antiderivative here. Okay. And when we get to the point that we are incorporating all of our integral rules kind of together and having to make a distinction between which rules are supposed to be used, we're going to kind of think through similar thought processes here as far as like, for example, is this power rule? Can I somehow rewrite it to get it into power rule form? Is there something here that in some way, shape, or form indicates the use of a particular rule, like a trig rule? Okay? But once you sort of kind of remove those as possibilities, then we're left with our u to u substitution. So we're going to go ahead and look for our parentheses like we did back in Unit 4. In this case, our parentheses are around that 4x minus 1, because this is 4x minus 1 quantity to the negative 1, which means our du is going to be 4 dx. So the 4x minus 1 is going to be the u. We have 8 dx instead of 4 dx. That's easy to fix by multiplying both sides by 2. And so now we've got a prime u du substitution here. The 8 dx is going to come out, and the 2 du is going to go in its spot. And the 4x minus 1 is going to be removed with u in its spot, which is our natural log rule, 1 over u du, 1 over u du. This 2 is just a coefficient, and so it can just hang out in the problem. Okay? And then because our problem was initially given in terms of x, our answer needs to be in terms of x, and so I am going to substitute back in that 4x minus 1. And there you go. That's your rule. Pretty straightforward. Okay, so let's go ahead and do 2 more. Again, I challenge you to try to pause the video, do them on your own, start the video again to see if you are in fact understanding the material, if you are in fact able to apply kind of the basic natural log rule. Okay, so example 2 here. We have y prime equals x over x squared plus 1. So the integral of x over x squared plus 1. Again, it's not power rule because I can't rewrite it, etc., etc., etc. We'll get to the point where we actually think through all of those steps. For today, I'm just kind of miming them. Okay, so we get to the u to u piece. My u is what's in parentheses. In this case, it's that x squared plus 1. My du then would be 2x dx, which the x squared plus 1 is there. The x dx is there. The 2 is not, but that's easy to fix. Go ahead and divide that 2 over to the other side, just like we've done since Unit 4. Okay. So the x dx comes out, the 1/2 du goes in its spot. The x squared plus 1 comes out, the u goes in its spot, and we've got right here 1 over u du, that's the natural log of the absolute value of u plus c. And the 1/2 just hangs out. And then again, put back in that x. Okay, so one more here. Example 3. We have y prime equals 3x squared plus 1 over x cubed plus x. Okay, so again, evaluate, can I rewrite, can I get into power rule, etc., etc., etc. Nope, nope, nope. So, u to u, look for your parentheses. U would be my x cubed plus x. Du then would be 3x squared plus 1 dx, which matches up perfectly. We have the 3x squared plus 1 dx, which is going to come out and be du. X cubed plus x becomes u. And that really is truly a straightforward natural log of the absolute value of u plus c. And then substitute back in your x. And there you go.